Hi everyone, it's Dan Bentley, and I've got some general feedback from your unit test 3. I've got a few select questions, the ones that weren't as based on your calculator, that I'm going to go through here with you. So let's move on and let's look at question 1. You need to solve this equation, secant 3x minus pi plus 2 equals 0, and please take note of that domain. Okay, so I know that secant, first I'm going to just kind of pop that 2 over the other side. Secant is the reciprocal of cosine. So the great part is then if I can kind of just use the reciprocals and equate them. So now I'm equating cosine of this angle to equal to 1/2. Now you may want to, hopefully you're getting pretty good with your unit circle or your chart, however it is you remember angles. But then I can say that this angle is equal to, now look at, I'm writing several angles down here. See, I'm looking at my unit circle and I'm saying, okay, when does cosine equal negative 1/2? Okay, and I maybe want to go around the unit circle from both the negative and the positive side and write down several angles. It's better to write down more possibilities than less. And also you want to maybe think a little ahead and think, well, I'm also going to be cleaning off this x, solving for x. So I need to think about what angles that I will have that will fall into my domain, which is 0 to pi. So I've written down 3 angles, and let's see how that works out. Okay, first of all, now I'm going to add x to both sides, to all of these pieces. So adding x, think about it, I'm adding 3 over, sorry, excuse me, I said x pi. I'm adding 3 over 3 pi to all of those, and I get these angles. And now I'm going to divide all by 3, okay, or multiply by 1/3, which gives me pi by 9, 5 pi by 9, and 7 pi by 9. Now, you think, oh, would there be any other angles within the domain they're giving me, 0 to pi, right? And so you need to consider that, and in this case there won't. Those are the 3 possibilities for this solution within that domain. Okay, so make sure you're listing those possibilities. Okay, next we're just moving on to question 3. Okay, so you have a triangle here. The first thing I did, it's a right angle, so I'm probably going to use right angle trigonometry, or SOHCAHTOA. I quickly found the hypotenuse of these sides because it's a right angle using Pythagoras. And then I can set up some trig ratios here. I know that cosine of alpha is 3 over 5. Cosine of beta is 3 over root 13. Sine of alpha, 4 over 5. And sine of beta is 2 over root 13. So now if I'm looking at this, the question says find the exact value of cosine alpha minus beta. Now that kind of rings a bell. That looks to me like one of my compound angle formulas. I'm starting to recognize these now. So then I can look this up in my formula book, and hopefully maybe I'm starting to memorize some of these. This is my compound angle formula. And the great thing is I have just solved all of these, so I have all the information I need right there. And I can just simply plug these in. And I just have to do some simple math now. Multiply through, subtract the 2 from each other, and I end up with this answer, and I might just rationalize that denominator, and I'll get 17 times root 13 over 65 is my final answer. Okay, so that's using your compound angle formulas. Next we're going to look at this question here. This actually wasn't too bad, and if you're looking at the mark scheme, I'm sure you've been able to figure this one out. So I'm going to start off, I'm going to talk about this minor segment, this kind of shaded area here, and notice that both my, I've got r for my radius, I haven't been given a number, I'm just going to use r. So I want to show that the area of the minor segment is that, and I know that the area of that segment there is going to be the area of the sector minus the area of that triangle. And area of a sector is 1/2 pi r theta. Excuse me, it is not. It's 1/2 r squared theta. And then the area of a triangle is 1/2 r squared sine theta. And in your formula pack you would see that as 1/2 ab sine theta. But notice both our a and our b are radius here, so r. I'm just going to notice that I have a 1/2 and an r squared in both of those terms. I'm going to factor that out, and I have got what they asked for. In B, I'm going to find the area of the major segment. So really, the major segment is just the rest of that circle. So to find that area, the rest of this circle, I'm just going to take the area of a circle, pi r squared, minus what I just found, and that's what it is. Now, let's talk about this question was a little more difficult. So I've had to find the ratio of the two areas. So here I can basically say that my major over my minor segment is 3/2. I'm just going to plug in the formulas that I found in A and B part for major and minor and equate that to 3/2. I'm going to cross multiply, and this is what I get here if I cross multiply. Now I'm going to look through. I think I can pull out an r squared in every term there. Actually, also multiply through by a 2. That makes my life a lot easier. I multiply both sides through by a 2. Pull out that r squared, and so now I can cancel an r squared off both sides. I can work this through, collect up my like terms, and divide off this -5, and lo and behold, I have what we were looking for. So that's pretty cool. I like the way that one worked out. So hopefully you're able to follow through with that. If I'm moving on now to this question where we had to we constructed this triangle, and this is quite a common question in the IB circles here, because often it's going to end up having two solutions, and it might bring you to a quadratic equation. I think this one's easier solved by the cosine formula, although it is, and you'll see on the mark scheme, you can do it by the sine law as well as the cosine law. So I'm drawing a quick. Make sure when you're drawing this, you're careful about how you draw it. That you draw, you label the correct sides and take care on where your vertices are. Okay, so I've come up with this. I'm going to solve for x here. So I'm going to use the cosine law, which is 6 squared equals x squared plus the other side squared minus 2ab sine c, right, if you remember that. Now, if I tidy this up and set it equal to 0, you'll see that I actually just have a quadratic equation. Now, I've kind of let this go to 4 decimal places, but you can also just store those values in your calculator, and you can get it accurate to more decimal places. That's kind of more recommended. I can graph this thing, or I can use one of the solvers on my calculator, and I find out that this is 4.2 or 9.60. And think about why that happens, right? This is the ambiguous case of a triangle, right? This is angle side side, if you remember that from your geometry days. And so if I was looking at a triangle like that, sure, that side could be 4.2, or I could look at a triangle with a longer side, and that could be 9.6. Okay, so that's why it works. Again, you could do this question with sine law. Okay, so check that out. It is in the mark scheme. Question 8, the first part of the question was more calculator question. I'm sure you're okay doing that with your calculators. Check the mark schemes for your answers. But this one was a little more sort of, algebra intensive here. So I said that my cosecant was 1 over sine x, and then I just said my sine was, my tan 2x was sine 2x over cosine 2x. And as soon as I see a sine 2x and a cosine 2x, I automatically think of those double angle formulas. And so I wrote them down. Now there's a couple options for that denominator. There's a couple double angle formulas that deal with cosine 2x. But I'm looking ahead and I'm seeing at the finish line I've got a whole lot of cosines, so I'm going to try the one that deals with cosines. Okay, now I need to add these two things together, so I need to get a common denominator. Also looking ahead, what makes fractions equal to 0? What's when the numerator is equal to 0? So as I get a common denominator here, I'm going to multiply the numerator on either side by each denominator, and this is what I get. So anyway, my denominator actually at this point becomes irrelevant because I'm just equating my numerator equal to 0. So as I do that, I'm going to tidy this up. I also see, wait a minute, that's a sine squared x in there. And I don't want a sine squared x, I want a whole bunch of cosines. So I use my Pythagorean identity here and go 1 minus cosine squared x. I'm going to distribute this through, tidy it up, and you will find maybe you might want to throw in a couple more steps, but you'll find that you can get down to what they are looking for. Last part of the C part of this question, okay, I'm going to plug in pi minus x and also pi plus x to both of these and see what happens. Now these aren't as common of formulas, but if you have a question like this and you play around with it and you think about what that might be, try some values in your calculator and see. You will notice that the sine of pi minus x is actually just equal to the sine of x. And try it. Try true values. Put in x as pi by 6 and see what happens there. The same goes when you're working with tan here and 2x. Try some values and see what happens, and you'll find out that you come out with tan of 2 pi minus 2x is actually just the same thing as minus tan of 2x. So it's just the negative. Okay, so go ahead and try some values and see that that works. Okay, and then now I'm going to do the same thing again, but this time with pi plus x. And here this comes out with a, so pi plus x. And then you'll find, again, try some values, you'll find you'll get negative 1 over sine x. And this will also just be a positive tan 2x. Okay, and then the question asks you to add these together, and if you add them together, you'll see that they kind of cancel each other out. One is negative where the other is positive, and so you'll see that it does. Let me just finish this off here, and you'll see that it does equal 0. Okay, so that's all I have for you here. I hope that helped. There was several questions. There was a lot of calculator work as well on this test, so hopefully things went well for you. And if you have questions, you can take them up with your teacher as well. Okay, thanks very much.